So this is the video demonstration for the Suzuki reaction of target B. So I'm going to start by taking my reductive amination product and dissolving it in THF to make a 0.5 molar solution. Okay, and don't worry too much if this doesn't all go into solution at this stage, because when we heat it up it will. And I'm going to add this to my phenyl boronic acid and phosphine ligand in a carousel tube with a stirrer bar at the bottom as well. And I can just rinse this out with a little bit of extra THF. Now I'm going to degas this mixture for about 20 minutes with nitrogen to remove any oxygen that might interfere with the reaction. And so in this case I'm going to bubble nitrogen through the solution using a balloon of nitrogen. You could equally use the nitrogen tap on a fume hood or directly from a cylinder. And I'm going to get this stirring. Top. You should be able to see a stream of bubbles bubbling nitrogen through the solution. And in the meantime, I'm going to do the same with a solution of sodium carbonate in water in preparation for the next step. Okay, so the solution's been degassing now for about 20 minutes. Swap this needle for a shorter one so I can keep the reaction under nitrogen. And I'm going to add my palladium catalyst to the solution. Finally, I just need to add my 1 molar sodium carbonate solution, which again has been degassing with nitrogen for the past 20 minutes. And this can now be heated at reflux for about 2 hours. Okay, so the reaction's been stirring for about 2 hours now. So I've taken it off the heat, cooled it down to room temperature, and now I can dilute this with water, extract it with ethyl acetate 3 times, wash the combined organic fractions with water and brine, and then dry it with mag sulfate, whack it down to afford my crude final product. So as you can see, now that we've finished the workup, the product's come down to a yellow oil, which can now be purified by column chromatography. Okay, so I've completed the workup now. The product has come down to a nice yellow oil, and I've developed some TLC conditions. I'm going to go with 10% ethyl acetate and petrol for the column chromatography to purify the sample. So I've already prepared my column here. This is the glass chromatography column. You can see I've got a layer of cotton wool, then sand, and then my packed silica on top of it, which forms the stationary phase of the column. And so to prepare my sample to be loaded on top of the column, I'm going to add a small amount of dry silica to it. And then I'm going to dissolve this up in DCM. And then use a rotary evaporator to concentrate this down and get my product adsorbed onto the silica, which I can then dry load onto the top of my column. So as you can see, I've now evaporated down my mixture with the silica in it. It's come down to a nice fine yellow powder, which can now be loaded onto the top of the column. I can elute my solvent through to separate the compound out. So as you can see, I've collected plenty of fractions now. I've just taken a TLC. So to start with, I took a TLC with a grid matching up with the fractions that I've collected to tell which fractions actually contain any material at all. And then using that, I can TLC a smaller number of fractions to know which contain one spot. As you can see, as we get towards the end here, an impurity starts to elute. So I will combine the fractions that contain one spot and evaporate them down to afford my final product.